Here we are, it's November, and we've been receiving so much positive feedback about the work and the communities of practice, especially around the Math Fix and how you're sharing them with your students and the discussions you're seeing in your classrooms. So please keep that coming, but without any further ado, here is our latest Math Fix.
Math Fix centers around 6.ee.1, writing and evaluating numerical expressions involving whole number exponents. This Math Fix is all about that keyword, evaluate, with respect to expressions with exponents and also order of operations. In this Math Fix, students are asked to replace the missing value in each of the three expressions with any integer, so long as you use the same integer in all three. Then they must evaluate if one of those expressions would always have the greatest value or if one would be the smallest. They must also support their answers. The wording of this Math Fix can be a bit tricky, so decoding and vocabulary help up front may be necessary to get students going. Integer may still not hold negatives for them. They may still be in the positives, but I wouldn't remind them right away about that. Let them make some progress with positives, and then once they have a firm footing on the problem, maybe bring up the idea of other values for integers that aren't positive. And remember, 0 is an integer too. Each expression has a specific value missing that is key to this problem. If we were to pursue the greatest value by putting in a large value in each expression, the effect would be different for each one. For the first expression, a very large value like over 81 here will turn this portion of the problem into a value less than 1. This keeps the overall expression sort of small, but always positive. The middle expression gets very large quickly with a large value put into the missing space. The cubed exponent does nearly all the work needed to make this expression grow. For the final expression, a large input for the missing value would affect the right side of the expression, but the missing values placed in the expression only has a minimal effect on its growth, and it would only be 16 more than double the value we put in. Put a large number in for the missing expression value, and the middle one is always the greatest. But if we were to test for the smallest value, well, for the first expression, a small positive value would turn this portion of the problem into a value less than 81. The overall effect of the entire expression stays fairly close to 81. With the small integer for the middle, it stays relatively close to 16, and the cubed exponent does not do much when we put in a value of 1. For the final expression, a small input for the missing value does not change the right side of the expression much, and it would only result in something close to 34. So put a small number in for the missing, and the first expression is now the greatest. But put in a negative value for the missing number, and the same patterns as seen originally form, but the first two expressions go negative, and the third might stay positive or to go negative, depending on the size of the negative input integer. With an input of 0, the third expression becomes the greatest. So what we see here is that students will have a lot to talk about when predicting the results of the greatest and smallest expressions. They can talk about the effect certain operations and order of operations has on the resulting values. Let your students go with this one, and they should have no trouble exploring this fun task.
Well, that's November's Math Fix. Thank you for participating. Thank you for being involved in all of our Math Fix this year. Keep that feedback coming, and we'll see you again in January.